into the water, and then under the water. Cyclops, a new manned submersible, now undergoing sea trials.
There you go. That's pretty good right there.
Okay. Yeah, you're still mud.
Okay, see the mud?
Yep.
She's doing great. It's been a very pleasant surprise. When you put a sub in, you don't know if she's going to handle as well. You aren't certain if you're going to have systems have failures, but she's been a great machine.
Cyclops is the newest creation of OceanGate, a for-profit private company in partnership with the University of Washington's Applied Physics Laboratory.
We couldn't have done it without that partnership. You know, the Applied Physics Lab has been effectively our engineering partner.
APL UW's David Dyer explains how the lab works with OceanGate.
We had to get creative on how we can actually pull this work off and be able to have a reasonably priced project output for OceanGate.
The key, APL provides brainpower and skills as needed.
So we've been able to move people in and out of this project, and that's what got back to one of those financial challenges on there. Is how do we get Stockton all the expertise he needs in an affordable manner so he's not having to carry this huge overhead on this project. So we can bring someone in, charge a couple hours to it, and let them go off and they go back to their own projects and their own work on that.
APL UW scientists and engineers faced some major challenges, starting with how to design a deep diving submersible that you don't have to be a U.S. Navy submarine skipper to operate.
Stockton is very interested in being able to quickly train pilots, have pilots be able to come in and use this thing without having to go through weeks of training on there.
Solution? This video game controller.
Combination steering wheel and gas pedal, which is this device. This is a Sony PlayStation PS3 gaming controller. And with this device, we can drive the submarine, make it go up, down, left, right, forward, and backwards. The main challenge probably was learning how this device communicates with a computer.
APL's Pete Brodsky designed the Cyclops control system and the complex electronic paths from the controller to the submersible's thrusters.
In a nutshell, the electrons from here have to make it through about 10 different channels of a computer, out fiber optic, into another device, which turns it into an analog signal, out to a motor drive, which then generates high-power electrical signals out to the thrusters. Getting all that connectivity right was interesting and challenging, but we believe we have it down now.
There's aspects of it that are groundbreaking.
David Dyer tackled the impact of hull design on efficient energy use, developing an evolution from earlier, boxier OceanGate submersibles.
When you look at the Cyclops shape, there was a lot of effort put into it to make it look neat and cool, but also to make it so that it was functionally, hydrodynamically efficient.
Efficient without compromising the pressure hull.
We are now taking a pretty significant exoskeleton structure, having to attach it to the primary pressure hull.
That's good. Come on in. I think we can push it over.
You can't put holes in it. We didn't want to weld to it. We had to do it in such a way that we didn't impact the functionality of that pressure hull. So technically, that was a big challenge for us.
With Cyclops nearing operational status, the next step is the marketplace. The basic pitch?
Cyclops is going to be a very useful tool for any organization, company, or institution that needs to go underwater and perform tasks at depth without requiring a very expensive support ship and other apparatus that would be associated with a remotely operated vehicle.
To get the word out, a Cyclops roadshow is planned.
It's going to include dives in the Gulf of Mexico, off the East Coast, and off the West Coast, as well as dives here in Puget Sound.
And expect media events along the way, similar to Seattle rap star Macklemore's dive aboard OceanGate's Antipodes submersible for the Discovery Network. The spotlight will be on Cyclops, product of the partnership with APL UW that made it happen.
If this thing makes it, and if this thing goes off and it starts becoming a big deal, it's actually a model that we can then hold up and say, look, this is not something that only works for OceanGate. This is something that will work for other people and get them help on getting that up and running and move off and become an impact in the economy.
Science at work for you. This is APL, the Applied Physics Laboratory at the University of Washington in Seattle.